Hi, we are given that ABCD is a square with area equals to 1. PQRS are midpoints of the size of the square. And we want to find the shaded area in red. The first thing is I like to consider this right triangle. And I'm going to make an exact copy of this right triangle. I'm going to make an exact copy of this right triangle. So the short leg, long leg, hypotenuse, short leg, long leg, and hypotenuse. It is a 90-degree angle. Let's say this is the angle theta. It's the angle between the short leg and the hypotenuse. Short leg, hypotenuse. It is angle theta. Let's say that is angle beta. This one will be angle beta, 90-degree angle. Well, theta plus beta equals to 90 degrees, so this one must be a 90-degree angle. And now I'm going to make a horizontal shift. I'm going to bring this triangle over here, shift it over here, and do it one more time. All right. And now three sides or three segments must be parallel because I'm doing a horizontal shift. So these two angles will be 90-degree angle. I'm going to do the same thing over here. I'm going to make an exact copy of this and put the triangle over here. So that is the 90-degree angle, and then there's angle beta, and then there's angle theta. Okay? All right. And these two triangles are congruent, so there is beta as well. So this angle will be a 90-degree angle. I'm going to bring this triangle down. I'm going to make a vertical shift. Bring it down. Bring it down one more time. Bring down this triangle over here. So these three sides must be parallel because it is a vertical shift. So if this is 90, this one will be 90. And this one will be 90 as well. So this one looks like a square, but we still need to show that it is a square. Take a look at these two triangles here, all right? They're both right triangles. And then there's angle theta. This one will be angle theta, corresponding angles. So this one will be angle theta, 90-degree angle here. So that is angle theta. So that is angle theta, because it is 90. All right, and these two segments are congruent, so these two right triangles are congruent by angle side angle. All right, and this is the long leg. Let's say the long leg is x, so the long leg here will be x as well. So these two segments are congruent. And now take a look at these two triangles here. This one and this one. They are similar triangles. 1 to 2. The ratio here is 1 to 2. So here is 1 to 2. So this one has to be x. Now look at these two triangles here. This one and this one. Since they are parallel, they are similar. So 1 to 2. 1 to 2. 1 to 2. So this one is x. Since this is a parallelogram, so opposite sides are congruent. So all sides congruent. So that is a square. Actually, that is a square. And now I'm going to connect this point to that point. That is x, that is x. 90-degree angle here, 90 here, 90 here. So this one has to be 90. That is a parallelogram, and so that is x, and that is x. So actually, that is a square also. And now I want to show that these two triangles are actually congruent. That is angle theta, that is angle theta. That is 90, so that is angle beta. And these two are congruent, so actually they are congruent by angle sine angle again. And seems that we can cut this triangle out and put it over here. Cut and paste and bring it over here. I can do the same thing over here. Let me do it this way. I'll do it over here too. Do the same thing over here. So these two triangles are congruent. Cut and paste. The same thing over here. Cut and paste. Bring it over here. Cut this triangle and paste it over here. Cut out this triangle and paste it over here. So the original square have been transformed into 5 congruent squares. This one is off a little bit, okay? Have been cut into 5 congruent squares. Make it look a little bit nicer, okay? So the shaded area, the area of the shaded area will be 1/5 of the 1/5 of the area of the original square, which is 1. So the shaded area is actually 1/5 of the original square. And I think that is it. And thank you for watching.